to find the average rate of change over the interval is to also just find the slope of the secant line that goes through the graph at those 2 points. So at -8 and at +8, if we draw a secant line in, just to get a visual here, we need to find the slope of that line. And we can tell it's certainly positive, and it's certainly less than 1. So we should get a positive proper fraction for an answer. Now to actually do the math, we need to figure out delta y over delta x, that's the slope of the line, on the interval -8 to 8. So we've got to figure out how tall the graph was at the end of the interval minus how tall the graph was at the beginning of the interval. That's our delta y. And then you simply subtract the end x value minus the beginning x value for your delta x. And our function was, just as a reminder, 10x over x squared plus 1. So we plug 8 into this function, we get 80 over 65. We plug -8 into the function, we get -80 over 65. And the whole mess is going to be over 8 minus -8. That's like 8 plus 8, which is 16. To simplify this, 80 minus -80 is like 80 plus 80. So we have 160 over common denominator 65 times. So instead of dividing by 16, I'm going to call it multiplying by the reciprocal, 1/16. I can simplify 160 over 16 is like 10 over 1. And I get 10/65, or maybe better yet, 2/13. So 2/13 is the average rate of change. 2/13 then would also be the slope of this secant line that we've drawn in, which seems pretty reasonable given what we're looking at.